Now have Curtis, who will be speaking to us about JavaScript classes for the Python programmer. Over to you.
Good afternoon. I'm going to be spending a lot of time standing this way because those lights are quite aggressive. Thank you. Just a quick introduction of who I am. I've been working with Python for about 25 odd years. I've been working with Django for about 16 years, long enough that they actually invited me onto the core team at some point. And I'm here with many thanks to my employer, who is the reason I had to do the investigations that led to me coming to the realization this content needed to be shared. I'm going to cover a lot of the differences and similarities between how classes and objects work in JavaScript versus Python, because that helps us all, especially those of us who work in the web space. Let's start off with some very basic fundamentals. In Python, we have explicit classes. You say class, you go name, you define your class, and there it is. In JavaScript, it's a little more subtle. Every object can be thought of as a class, pretty much. When it comes to scoping, in Python, we have self, and that is explicitly passed into your methods. It's injected for you. You don't have to remember. It's just attached. And this is done, I discovered a couple of years ago, using the descriptor protocol. So anyone who's familiar with @property, the same functionality in classes that lets that work is how functions know to inject self when they're called as part of a class. In JavaScript, it's a little different. What happens is you have a this object, which is the scope from which you were called. If you are called via looking up another object, then that object is your this. You can actually play with that and lose that if you're not careful when passing functions around. In Python, we can actually trick Python into injecting a different this or a different class as around. We can call a method on another class with our this by actually calling the class method, not the instance method. On JavaScript, they have this thing called bind, which is a method on every function, so that you can say, when this gets called, I want this object that I'm passing to you now to be my scope, to be my this. Next is properties or attributes on our objects. In Python, every instance has a type, which is its class, and when you look up a property that doesn't exist on your instance, Python will then go look it up on your class, and then its parent class, and so on until we reach object, at which point we say, oh, you haven't got one. In JavaScript, okay, I've got my fragments out of order here. We can, in Python, actually test if there is a direct attribute on our class by looking at the dunder dict of the class to say, if this name is in there, then it has that on itself, it's not inheriting it. In JavaScript, every object has a prototype, just one. When you look up the property, it doesn't exist on your current instance or your current object. JavaScript will go and look at the prototype, and then there will prototype, and so on until you reach the null object, or there's no more prototypes to go up to. So it's very similar in way to the Python's climbing up the tree, except it's directly on your object rather than the type of your object. Additionally, in similarity, we can ask the object class itself, they provide us a static method to say, hey, does this object actually have its own instance, its own attribute, or is it inheriting it from its prototype tree? Next, we'll step on to constructors. Now, in Python, we're all familiar with the dunder init method, which is we can define on our class to say, hey, let's get set up and let's get ready to go. In JavaScript, you actually write a function that is not directly part of your class, which constructs your object instance pretty much the same way. It's very similar, as we can see. You can do the same things. You assign values to this. In Python, we can create our object using the constructor by calling the class. Init gets called implicitly when we do this. In JavaScript, you invoke the constructor function, and it returns you the newly constructed object. Inheritance, again, it's a little different in basic objects. In Python, we actually say that my new... Sorry, I've got the wrong glasses on, I'm having trouble reading. Any attributes on our class are inherited by the instance. This way, that when we've put a method there, which is an attribute on our class, we can access it that way. In JavaScript, objects inherit via their prototype of their constructor. So my class instance on the left has inherited the greet function from its class. On the right, the JavaScript function is inheriting the greet function from the prototype of the function. We've actually added it that way. And so instead of when it's constructed, it inherits the object prototype of the object it inherits the prototype of the function that constructed it. Static methods on the class itself or on the constructor, very similar patterns. In Python, we actually have a decorator to say this is a static method, so it won't be passed a class or an instance. And we can often use that as factory functions to produce new instances. In JavaScript, because it's inherited from the prototype of the parent, or with the prototype itself, we can attach objects and methods and attributes directly to the function, which is an object very much like in Python. So invoking this, here we would get a mock object from a Python class, and here in JavaScript, we call it the same way. It looks very much the same. We get an object back. It's just a method, a function attached to the function object, which is our constructor. Now, subclassing in Python is a very explicit thing because Python explicitly supports classes. So if we just say that in my definition of my class, well, it's a one of these with these changes. And when I wanted to go and say, well, do what the parent class would do, I call super. In JavaScript, it requires a little bit more effort because it's a constructed concept rather than a native part of the language. So we have to tell our constructor that we're creating now that its prototype has a prototype of the parent class's constructor. And that sounds a little bit roundabout, and actually doing that is also a little bit roundabout. So here we've defined our new constructor, and it calls the parent class's constructor using call, which is similar to bind, but it actually, you pass it the scope and then the arguments as a list. And then we have to say, can we create a new copy of our parent class's prototype, but add to it this constructor, this is a very explicit and detailed way of saying, I want to put another property on there. Very tedious. Next, we come to a very noticeable difference in terminology and functionality between Python and JavaScript. Python's init function, although we often refer to it as a constructor, is not a constructor. It's there in the name, it's an initializer. And this difference means that it's only invoked after the instance object is actually created. And by the time that we get to the instance and we get to our initializer, all the properties are declared on this instance. All the properties have been inherited from the class, the parent class, all the way back. And all of those attributes are visible to even the superclasses methods once they're called and invoked via super. So here's an example. If we have a Python class called unit, and it has a property called foo, and then our initializer, we get bar, and we ask for the amount and multiply them. When I create a chunk as a subclass of that, if I create unit with a 2 value, it's 2 times 1, we get 2. Chunk, 2 times 5, we get 10. Pretty straightforward. If we tried the same in JavaScript and we call new, what happens is we get a blank object created, then its prototype is set to the constructor function's prototype, then the constructor is called with this new object cast as it's this. I've got my slides out of order. I'm sorry about that. Next, we enter ES6 or ES 2015, JavaScript released in 2015, which introduced a whole bunch of things, but one of the nicest things it introduced was class syntax. This allows us to redo all those things we'd done before in a syntax that looks a lot more like other languages' classes. Now we have an explicit constructor function. We can define static methods and static properties and inherited functions for everybody else to use. Now subclassing becomes a nice, direct, clean, this class extends that class. My constructor calls the superclass's constructor and then does whatever its local things are. Unlike Python, and very much like a lot of other languages, JavaScript does not support multiple inheritance. You can go up the chain one by one, but you can't say that this class mixes in multiple classes. Another important difference, and this is actually different from the constructor functions we saw earlier, is that you must call your superclass constructor before you do any modification of your this object. If you try to do it, you'll get an error like this to say exactly that. Again, static properties can be declared just like they were before, very much like in Python. Now we just put it inside the class declaration and invoke it directly from the object itself, the constructor, rather than as a member. And prior to ES6, it would have looked very much like this, so it actually hasn't changed a lot. It's very, very similar. Next, I want to talk about what I'm calling subclass overrides. So our example before, where we have an object which takes a factor, a scaling factor, and then we pass it an amount, and it'll tell us an amount comes out. And then we have a subclass of it, and it gives us a different amount, because the init function has gone, oh, okay, I'll put that number in, I'll multiply them, and out we come with our amount. In JavaScript, if we tried the same thing, looks almost identical. We have our constructor, we have the amount, it's times the factor, and out we get is a 2. But if we try the subclass, why did we get 5? Why did we get 2? The wrong number comes out. Why does the wrong number come out? Part of the problem, and part of the big conceptual difference, and what I was talking about with the constructor versus initializer before, is that JavaScript constructors are called in order. Because you have to call your parent constructor before you do any work, that goes all the way back to the root object, from the bottom all the way back up to the top. There's this layered concept, and each layer can only see what's been defined so far, what it has attached to the construction. Which means that all the methods, all the overrides, all the shadowed attributes you've got on your subclasses aren't there yet. Additionally, public fields, which is like our factor 1 here, are added just before calling the constructor function. So what has happened in our example is that factor was actually 1 when the scale constructor was called, and therefore, when it has set this dot amount, it has gone and multiplied it by 1. Then, when the bigger class gets its static attributes or its class members set up before its constructor is called, then the factor is set to 5. This is a bit of a trick that catches you out sometimes. So how can we fix this? What patterns can we follow to avoid this problem in future? First, you can use it as a static member and then explicitly reference the constructor that was used to trigger this construction in the first place, rather than your current version of the truth. This way, we stash the static property on the constructor, and then we go and reference whichever one was there first. So here's an example of that code rewritten. We have a static factor instead of factor. And here in our code, we say this.constructor.factor, we're referring to whichever constructor was used during the construction initially of this object. So it will always be the constructor that was passed to new, rather than the current constructor that we're calling. Next, we can actually use this layering effect to our advantage. So, since we know that they're going to get called in that order and that the object's going to exist in the particular state as we get there, we can use static initialized fields as they're evaluated during construction. So as it's a layered thing, we can use this to provide helper methods for next classes down to access. This is a natural thing in Python because we already know that all those methods are put together already. But we can do this as a deliberate effort in JavaScript to make things a little easier to use. So as an example, we might, on our base class, have a setUpThings method, and then as a static initializer during our child class, call that to say what this field should be. Now, notably in this scope, this is referring to the object that's under construction, and super is our parent class or the constructor, just like when we're using a constructor function. Static initializers are public fields, just like we saw with factor, and the class can have its own static initializers as well. So we've already seen a very basic case of this, with static initializers being methods and properties that we define on the constructor object itself or the base class. But they can also be methods and include whole code blocks with conditional work and so on to make it initialization of things that do not depend on the arguments passed into your constructor, or may only depend on arguments that have already been handled by parent classes. This is a nice way to make your constructor functions a little tighter, a little smaller, so that they are more focused on what the user has decided rather than what you've decided as a general practice. I'm going to include here a nice practical example by using the static initializers, our base class can actually provide helper functions for the other class to set up its own static methods. Here is an example of an enum class, and we say that we've got setup values as method, and then our enum class does in a static constructor block that we're going to call that method with a bunch of values. Here we can see it simply maps over the values and tries to set on this the uppercase version of that name and then the index back to the value. And the product of this output is that we now have an enum very much like Python, where I can look it up by name or I can look it up by index. All right, and this has gone just a little bit faster than I was hoping, but there we are. I'm done. Any questions, please?
Thank you, Curtis. Yeah, we have time for some questions. Oh, we have one there.
Oh, it's a Russell. Of course it's a Russell.
Thanks very much. A lot of the issues or the causes of confusion in the JavaScript class world seem to stem from which this is this and which one is that and so on. Any tips, tricks, suggestions, hints for how to either diagnose or prevent error when you get into that kind of situation?
So the biggest one was actually mentioned early on here. We're talking about how, and I did want to provide more detail on this. This is good. This, when you call a function, is the scope you were called from. And if you looked up via an object, as I show here, x.foo, then in this case, x is the scope of, it is the this once you're called. So if you remember to always look up via a function, then you can control your scope. If you are passing a callback to, which is very common in JavaScript for a long time, like we're doing down at setTimeout. You have two options. Either you can wrap it in a new function that deliberately looks up your object to get that function, because if you pass the function on its own, you've lost this. The other is bind. Bind creates a new function which always has, in this case, X as its scope, as it's this. It's bound, it's fixed, it's done. You cannot undo it except unless you call bind again, or a call, as I showed later on, as another option. That way, you can say always, I want this. And you'll see this a lot in older React code, where the constructor of the class will go through and grab all of its methods and say, on the instance, the same name equals that function dot bind this. That way, it doesn't matter if you pass them as a callback or use them in any other way, they're always bound to the current instance to make sure that that scope doesn't creep away on you and disappear.
Do we have any other questions?
I really struggle with context switching between Python on the server and JavaScript on the client. It does my head in. Can you talk through the pros and cons of doing that, just suck it up, versus Node on the server versus a Python to JavaScript transpiler?
Ooh, that's an interesting one. So my personal view is, if I had the choice, I would not use JavaScript. But in the browser, we currently don't really have the choice. There have been some great examples shown at this conference that it's there. I would much rather have a single language. So I definitely understand why Node happened as a thing, because all the people who already had all their familiarity and expertise in JavaScript moved over to the server and went, well, I'm going to bring my language with me. Perfectly valid choice. I like the idea of going the other direction, which Russell has helped with and various other people have helped with, in bringing Python to the browser. At the moment, I find your best, cleanest option is really to understand both languages and use each one in its field. I have not played with any of the transpilers, but I understand that some of them have been around a couple of decades now. I don't feel that you're really going to get the best performance results if you're just trying to shim one to look like the other. And a lot of the times when we work in the web, the performance can really, really matter. So there's a lot of different takes on how to do that. JavaScript has definitely improved a lot over the last decade. I now find it much, much closer to Python and much more cleanly defined. And they are actually, in some places, dropping some of the old things that they found very painful to deal with. There's actually a speaker's note on this slide to talk about with, which is no longer, in fact, if you go to the Mozilla Developer Network, they say, don't use this. Some browsers have even stopped supporting it, where you could say, with X, call foo, and it would make X the current this. So that's an option that is in JavaScript, but no longer there. So JavaScript is maturing and growing and evolving. Python is too, and I think JavaScript is a lot less painful than it used to be, and a lot less scary than I used to find it. But I was hoping with this talk to get people a little more familiar with what you're going to stumble across when you start trying to use it, and why the things are constructed the way they are. Because it's important to recognize that the new class structure stuff that was there is really the old constructors and functions and prototypes with a new syntactic sugar on top.
Do we have any other questions? Guess not. Thank you so much, Curtis. Here's a mic.
Thank you.